Infrared inspections have revealed significant overheating problems in Challenger panels equipped with Type C breakers, particularly affecting 3-pole breakers controlling air conditioning units. Temperature variations as high as 110 degrees Fahrenheit above the ambient temperature have been documented, with the hottest points pinpointed at the breaker contacts on the panel bus. Several potential causes could be at play. Firstly, Challenger breakers and panels themselves might be the source of the issue. This could stem from loose or deteriorated connections at the breaker contacts, insufficient contact pressure, wear on the contacts over time, oversized or misapplied breakers that are not properly matched to the circuit's requirements, faulty or degraded bus material within the panel, or even manufacturing defects or inherent design flaws present in Challenger breakers or panels. Secondly, the air conditioning units connected to these breakers could be contributing factors. High starting loads from the AC units, compressor or capacitor issues within the AC units leading to excessive current draw, or improperly sized AC units that are drawing more power than the breakers and panel are designed to handle can all cause overheating. To mitigate these heat issues, several preventive measures can be taken. 1. Implement a breaker inspection and maintenance program. Regularly inspect and tighten all breaker connections to ensure a secure and reliable electrical path. Replace any breakers that show signs of wear, damage, or deterioration. Ensure that all breakers are properly sized and applied according to the circuit's specific requirements and the applicable electrical codes. 2. Focus on panel maintenance. Inspect and clean the panel bus regularly to identify and address any loose connections, corrosion, or other forms of damage. Replace or repair any damaged sections of the bus material to restore its conductivity and structural integrity. 3. Thoroughly evaluate the connected AC units. Verify that the AC units are properly sized for the space they are cooling and that they are functioning efficiently. Check for any abnormal starting loads, which can indicate problems with the compressor or other components. Inspect the capacitors within the AC units for any signs of failure or degradation, as these can also lead to increased current draw. 4. Implement load balancing techniques. Distribute the loads from the AC units evenly across multiple breakers to reduce the stress on individual circuits. This can help prevent any one breaker from becoming overloaded and overheating. 5. Improve heat dissipation within the panel. Install heat sinks with thermal pads on the breaker terminals to help draw heat away from the connections and dissipate it more effectively. Ensure that the panel has adequate ventilation to allow for proper airflow and prevent heat buildup. 6. Consider breaker replacement. Given the reported issues with Challenger breakers, consider replacing them with breakers from other reputable manufacturers known for their reliability and performance, such as Westinghouse. Limited information exists regarding similar overheating issues specifically linked to Challenger panels and Type C breakers. However, some reports suggest that several factors may contribute to the problem, including poor quality control during the manufacturing process, design issues with the breaker contacts that lead to inadequate contact pressure, and degradation of the bus material over time due to corrosion or other environmental factors. It is noteworthy that the overheating issue appears to be absent in locations where Challenger breakers have been replaced with those from other manufacturers. This observation strongly suggests that the problem is related to either the Challenger breakers themselves or the panels they are installed in. It is strongly recommended to consult with a qualified electrician to conduct a thorough assessment of the specific situation, diagnose the root cause of the overheating, and recommend appropriate corrective measures. This may involve a combination of breaker replacement, panel repairs, load balancing, and improved ventilation to ensure the safe and reliable operation of the electrical system.